If this capsule history of our progress teaches us anything, it is that man in his quest for knowledge and progress is determined and cannot be deterred.
When it comes to a game of pool, there are two ways to play. The first is familiar to most of us. Find the ball you want to sink, aim somewhere near it, and hope for the best. And you never know. Maybe eventually you'll get a ball in. Maybe. The other strategy is much more rare and requires much more skill. These players understand that the entire table is necessary for each shot. Even for seemingly simple setups, the player mentally measures out the angles and spin to determine exactly how the cue ball will hit the target. He doesn't just sink the first shot, he bounces away to line himself up for the next one. This method makes every shot more crisp, more effective. And let's face it, it looks pretty cool. A neat parlor trick, but isn't that a lot of work for little return? Mastering the art of billiards is by no means an easy task. And after all, it's just a game, isn't it? Not quite. When astrophysicists launch probes into outer space, they play a very real game. This is cosmic billiards. Take a satellite. A satellite can be any object. A probe, comets, space debris that comes into a planet's orbit. The important part is that the object isn't just speeding through space, it's accelerating. In December 1989, NASA launched the probe Galileo into space in hopes of reaching Jupiter. At its fastest speed, Galileo rocketed over 170,000 kilometers per hour, far faster than scientists could usually achieve. To do this, Galileo first flew not to Jupiter, but towards the much closer planet Venus. It entered Venus's orbit in what is called a gravitational assist, accelerating around the planet and slingshotting back into space at higher speeds, then whipped back to Earth for the same maneuver. Only after these two flybys did Galileo set its course for Jupiter, using the extra boosts to accomplish the mission. When Joe takes a difficult shot, he needs to hit a specific spot for the right bounce, then make sure the spin ricochets the cue ball in line for the next play. Astrophysicists are doing the same thing on a planetary scale. They carefully slip their probe into a planet's orbit, then catapult back off in a new direction even faster. But what about speed? After all, our pool player can hit his ball in the right direction, but without the right force, he will still miss the shot. The answer centers on gravity. A satellite must reach the escape velocity to shake the influence of the planet's gravitational pull. So, physicists just need to find the right acceleration to break from the mass at the perfect moment. Think of it as a pool shooter, hitting the ball with just enough force to overcome the friction of the table. Sound easy? It's not. Astrophysicists have to calculate the gravitational influence of everything close to the planet, all while the entire system hurtles through space at thousands of miles an hour. And yet, scientists continue to do this with each new probe. In 2018, NASA plans to launch the Solar Probe Plus, using multiple gravity assists to fly a mere 9.5 solar radii from the Sun, the closest ever attempted. It's one tricky pool shot. So, what should you know about cosmic billiards? Well, you could start with gravitational assists, using other planets to make deep space exploration possible. You could list off a few equations, like the escape velocity and acceleration from each planet needed to calculate these assists. You could say that scientists will continue using cosmic billiards in their interstellar missions. Or, you could just know never to challenge an astrophysicist to a game of pool.